Scientific notation. Vocabulary. Scientific notation is when a number is written as the product of a factor and an integer power of 10. Now remember, product means the answer you get when you multiply. So here we have a representing a number times 10 raised to the n power, where n is also a number. A is between 1 and 10. It could be equal to 1 but not equal to 10. And n is an integer. So remember that it's a positive or negative whole number or 0. Here you have 425 million. Written in scientific notation is 4 and 25 hundredths times 10 to the 8th power. 4.25 is a factor between 1 and 10. And here's product, so times 10 to the power of 8. So that's written as a power of 10. It has all of the parts for scientific notation. Big number 1. If the number is greater than or equal to 1, the power of 10 is positive. Big number 2. If the number is between 0 and 1, the power of 10 is negative. Make sure you remember these. Write each number in standard form. Standard form is the way we normally see a number written. Example number 1. Here you're given scientific notation 5 and 34 hundredths times 10 to the 4th power. Now to change it to standard form, you're going to find the decimal and move it the correct number of places. Look at the exponent, it tells you how many places to move the decimal. So since this is a positive 4, that means we're going to make the number bigger. So to make 5.34 bigger, you move the decimal to the right 4 places because the exponent is 4. So 1, 2, 3, 4 places. Where this arrow is where the decimal would be. Our new number is 53,400. Example 2. 3 and 27 hundredths times 10 to the negative 3rd power. Now because the exponent is negative, we're going to make the number smaller than 1. So in order for this number to get smaller, we'd have to move the decimal to the left. We're going to move the decimal 3 places to the left because the exponent is negative. So 1, 2, 3. Where that arrow is where our new decimal is. This is tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So this is 327 hundred thousandths. Write each number in scientific notation. Example number 3. I have 3,725,000. To change it to scientific notation, I need to make sure that my number is between 1 and 10. So right now my decimal is over here, and it needs to be right here between the 3 and the 7. So I'm going to count the number of places that that decimal would have to move. 1, 2, 3, 4, 5, 6 places. The decimal needs to be 3.725 times 10 to the 6th power. Now the 6th power, because I moved the decimal 6 places, and now let's talk about whether this 6 needs to be positive or negative. Well, it's going to remain positive because this original number is bigger than 10. If the original number is smaller than 1, then the exponent would be negative. Bigger than 10, positive exponent. Smaller than 1, negative exponent. Those were your 2 bigs. Example number 4. This number is smaller than 1, so that's a key that I'm going to have a negative exponent when I write it in scientific notation. Find the decimal. Here it is. The decimal needs to be such that this number is between 1 and 10. So the decimal needs to be behind the 3, but between the 3 and the 1. So our new number would be 3 and 16 hundredths. That number is between 1 and 10. Times 10, and it's always times 10 to some exponent. How many places did the decimal move? Well, it was here. 1, 2, 3, 4 places. So our exponent is going to be a 4. Now remember that because this number originally was smaller than 1, that means our exponent has to be negative. So 3.16 times 10 to the negative 4th power is how you write it in scientific notation. Example number 5. Order the countries according to the amount of money visitors spent in the U.S. from greatest to least. Now, a lot of people miss questions like this because they're not careful when they're reading it. So I underlined greatest to least. We want the biggest to the smallest. Here's a chart of countries and the money that visitors from other countries spent in the U.S. In order to do this, you're going to first examine the exponents. So I have 7th power, 6th power, 6th power, 7th power. And then I'm going to order the decimals. So obviously 7 is bigger than 6. So Canada and the United Kingdom are the two largest ones. Now I need to see which of those two is actually the biggest. So I'm going to look at my decimals. 1.03 and 1.06. Well, this is like $1.03 and $1.06. So this is bigger. So United Kingdom, UK, comes first. Then Canada. Now let's look at India and Mexico. These both have an exponent of 6. Now look at order the decimals. 1.83 or 7.15. Well, 7.15 is clearly bigger than 1.83. So Mexico would be the next greatest, and last in this problem would be India. They are in order from greatest to least by country. Example number 6. If you could walk at a rate of 2 meters per second, this is meters per second, it would take you 1.92 times 10 to the 8th seconds to walk to the moon. Is it more appropriate to report this time as 1.92 times 10 to the 8th meters per second or as 6.09 years? Explain. Well, 6.09 years would be more meaningful because you're going to choose a larger unit of measurement for the situation. You wouldn't represent your speed of walking to the moon in seconds, you would do it in years. It would make more sense. But you don't always choose the larger unit, it just depends on the scenario. So make sure it makes sense.